Okay, this is the video tutorial to model and cut the 7339 phone holder cradle stock. This is very similar to other pieces you use. This is going to be cut from bar stock, so the bottom surface doesn't need to be machined. It's going to be cut rough to length, and our stock width doesn't need to be cut. We do want to reference the dovetail prep specification called out on the drawing, which is drawing DSPV. Read through these notes. I'm not going to go into detail on it because I've gone over more than one of these preps. Okay, so again, we're cutting this profile. Let's start off in Fusion and we're going to model the end profile and do an extrusion of it. So if we go to Fusion, we're going to do a new design and we're going to save this off as the part number 7339 underscore rev underscore 5, I'm sorry, 0 underscore your first initial last name. And like all the other ones I've been doing, we're going to do a sketch. We're going to start off on the front plane. We're going to draw a rectangle, represents our part. We're going to do a relationship between origin and the middle of our top. We're going to take and make a line from origin to center of the bottom. We're going to highlight that with the left button. We're going to make it a construction line. We're going to zoom in. We're going to draw from one edge a line and then back up to 45. And on the same other side, we're going to do the same thing. Looks like I didn't get this thing horizontal, so you want those horizontal. The next relation we're going to put in is we're going to make these two lines collinear to each other. Now we're going to draw some lines here and here, vertical lines. If we look at our drawing, there's a little 10,000 step, and that's what we're doing. Okay, we're going to come back and we're going to trim these up using power trim. Yeah, it looks like we lost our center relationship with origin, so we'll fix that. I got this weird curly Q here. We're going to drag that down. Make sure it's approximately the same shape. I'm going to put in some equal relationships. So these two edges here should be equal. This little flat on both ends should be equal. And our angle should be equal. We're going to dimension our little step. It's 10 thousandths tall. Then we're going to go from top of the blank to this land. According to our drawing, that's 80 thousandths. And then we need to put an angle on our dovetail of 45. And now we need just overalls. So our overall thickness of our part is 1.18. And our width of the bar is, our width of our dovetail is 1.5. And this width is 2. So let's go ahead and put the 2 in first. And then we're going to have 1.5. Okay, so you should have a fully constrained sketch at this point. You don't have to derive it the same way I did, as long as your geometry is correct. Okay, we're going to do finish sketch, and we're going to do an extrude, and the length that we're going to do on our drawing is the longer of the two, in case our stock is cut longer as opposed to shorter. So we're going to go 5.66. And we should have our stock pretty well defined there. Now, if you want to bring a vise in, we would go over, and there should be a vise connected to the assignment. And that vise should be called generic Sierra College vise. Okay, so I'm going to bring that in. The version I have is 2025. It's going to ask you what size parallels to use. We're going to use the default on this one, which is the 1 5/8. Okay, and we want to rotate our vise in an orientation that matches how we're going to machine the part. That looks good. Hit OK. This part is about the width of the vise. It's a little bit shorter. We want to, in general, center our work pieces on the vise itself. So that's how I'm going to do the joints. We do need to unground the vise from parent. When you bring in your first piece into an assembly, it grounds it by default. And then we're going to go to assemble. We're going to do a joint, and I'm going to elect to use a width. Okay, so I'm going to pick the width of the vise jaw from our first selection, and we're going to go to width of our part. And then the snap points are going to be front center, with the disc splitting the plane in front. And don't worry about the preview being funky, and hit OK. So there we go. We've got our work piece roughly centered on the vise. And then we're going to set our vise spacing to 2 inches, because that's the width of our stock. Okay, so that's it for the design side of things. Try to look at the vise in an orientation that you could see where you're going to place the origin. I'm going to like to put it on the left. You can choose to put it where you need to. So we're going to go to manufacture, and we're going to go to setups, and we're going to create a new setup. And it's going to default to making stock around our entire vise, because it doesn't know what the model is. We're going to select model. We're going to actually select our part here as the body. Okay, and on stock, we're going to do relative size box, but on the side offsets, we're going to put 0. And on the top offset, we're going to put 0.07 in as our height. That brings us up to a stock width of 2 and a stock height of 1.25 inches, which is our bar stock that we're starting with. And then we have our 5.66. So we should have about 70 thousandths to remove off the top of this, to skim off this bar. Okay, we're going to go back to setup, and we're going to go from Z-axis plane and X-axis. Select the top of the part. Our X-axis is going to be horizontal. Make sure the arrow is pointing to the right. We're going to go to a stock box point at the bottom left corner. We're going to go to stock, and we've got that set. We're going to go to post process. This is part number 7339 op1. We're going to call this op1. We're going to use work offset 1, which I'll put to D54 on a Haas. Hit OK. Okay, let's change our setup to op1. Okay, So now we're going to do some notes here. So we're going to right click and hit edit notes. We're going to put note 1, work coordinate system XY, coordinate system G54 XYZ origin is the left back bottom corner of stock. Okay. Note number 2, vise clamping pressure 8 foot-pounds. 3, use 1 5/8 tall parallels. Let's add the word inch in there. Alright, so that'll show up in the program comments on the setup sheet for your setup person. Okay, now we're going to face mill this with a end mill. Okay, so we're going to go and select from our library half-inch end mill. We're going to select the default geometry. On our heights tab, everything can stay at default. On our passes, we want our pass direction to be the length of the part. Our pass extension should be 0.26. We want it a little bit bigger. And everything else we can leave at default on this page. We're going to go to the linking tab. We're going to make sure the keep tool down button is, or box is selected. We want to take out our vertical lead-in radius. And we're going to hit OK. Okay, so there's our milling pattern to do the face. Now we're going to cut the release for the dovetail. We're going to do 2D contour 2D contour, and we're going to use the same half-inch end mill. And we're going to select our geometry, and we're going to pick the bottom edge of the flat on the dovetail on both sides. Okay, make sure the arrows are on the outside of the feature, like I have shown. Okay, we're on our next tab. We can go from model top to model top, and we're going to go not to selected contours because we picked an edge that's higher than where we're actually going. We want to cut to the top of the dovetail land. And if we look at the specifications document for the dovetail prep, it has a note 3, leave 3/1000 minimum stock for the dovetail cutter to remove on dimension C, which would be this flat here. So we're going to do that. In here we put in 3/1000. And then we're going to go to the next tab. We're going to use wear compensation. We are going to do roughing passes so that we get one finish pass. Let's set our step over 0.035. I'm sorry, 0.35. That's consistent with what we did on the face mill. And then our step over is going to be 0.010. Okay, and so that'll make the little flat on the end. And we may not need the rough pass because this land's pretty narrow. Okay, we're going to linking tab. We're going to leave everything at default except for we're going to keep the tool down. We're going to set our lead-in sweep angle at 0. When we do that, we have to have a linear lead-in that's greater than the radius of the cutter, so 0.26. And we're going to get rid of our vertical lead-in radius. And we hit OK. Should be leading in off the workpiece and taking 2 passes, 1 rough and 1 finish. Okay, now we're going to come in with the dovetail. So we're going to do 2D contour. We're going to select from our tool library our dovetail cutter. When you select this cutter, our current version of the library is putting a radius on it. So you need to go to edit, you need to go to the cutter geometry and put 0 in this corner radius. Otherwise it won't cut to the correct profile. That is going to generate the path that would go to the theoretical sharp. And we're going to hit accept. And if yours is modeled sharp in the current version or you've already fixed it in the library, okay, we're going to go to geometry. We're going to select those two edges. Make sure your arrows are on the outside. We're going to go to heights, and we're going to go from model top on both of these. We don't want to waste time feeding in. Okay, and we're going to go to the selected contour. We're going to go to the heights. We're going to go to wear compensation. You're going to pick rough passes. Our rough pass should be about 0.2. And we're going to do multiple finishing passes. And we're going to do those at 10 thousandths. And we're going to be skimming off the face of this. And we want to make sure that we're approaching it. We actually want to do 2 roughing step overs as well, because we're going to be skimming 30 thousandths off from the outside edge. Okay, now we're going to go to the linking tab. Again, we want to lead in from off the workpiece, so that's going to be 0 on that tab. We want to keep our tool down. Our linear lead-in distance has to be about a little over half the diameter of the radius of the cutter, so we're going to put in 0.19, and we're going to get rid of our vertical lead-in radius. We'll hit OK, and so we should get 2 rough cuts, 2 finish cuts. Only in the horizontal axis. Okay, that's it. Post-process this and make one setup sheet. Okay, I'll catch you on the next one.